Hello everyone, Dr. Polaris here. Like their dinosaurian cousins, the pterosaurs survived the extinction event at the end of the Triassic and went on to thrive during the following Jurassic period. In a video released earlier this year, I covered the early diversification of pterosaurs, charting their mysterious origins from presumably arboreal gliding ancestors to the development of fully flight-capable forms. For the first half of the Jurassic, these flying reptiles remained relatively modest in size, with generally narrow-toothy jaws and long tails. However, by around 179 million years ago, a new and significant clade began to emerge, one which would go on to be incredibly successful in the Cretaceous. These were the Monofenestratans, which straddled the line between the more basal Rhamphorhynchus-like species and the derived pterodactyloids, which included famous forms like the asdarchids, pteranodontids, and ornithochirids. This clade is defined by external nostrils that were aligned with a single large antorbital fenestra, which represents the major skull opening that lay in front of the eyes. This large single opening gives Monofenestrata its name, meaning one window. In addition, these animals showed a general trend towards increasing head size, increased length of the neck and wing metacarpal, modifications to the fifth toe that supports the rear wing membrane, and a gradual reduction in tail length and complexity. These features were also important in allowing more derived Monofenestratans to become competent terrestrial walkers, which would have significant ramifications during the Cretaceous. At present, the oldest known member of this group was the genus Melcamp from the Toarcian stage of early Jurassic Argentina between 184 and 174 million years ago. Represented by a partial skull and fragmentary postcranium, this small animal would have been about the size of a blackbird, albeit proportionally very different, with a big head, narrow-toothy jaws, and a possible long tail. Aside from its great age, Melcamp was also among the most basal Monofenestratans, indicating that the group may have first evolved in the southern hemisphere. Beyond this, it was traditional for phylogenetic studies to include a prominent clade known as Darwinoptera in a more derived position, also quite modestly sized. These animals were in many ways exact intermediates between Rhamphorhynchid-type pterosaurs and pterodactyloids, although it's still debated as to whether Darwinoptera is a genuine clade or not. First appearing about 179 million years ago, this possible group had a very wide range, with representatives having been found from China to Argentina to Scotland. The type genus, Darwinopterus itself, is also the best known form. Native to what is now the Liaoning region of China during the Middle Jurassic, roughly 160 million years ago, this genus is represented by multiple near-complete specimens, ranging from fully grown adults to small juveniles and even a singular egg, which is an incredibly rare occurrence for a pterosaur. About the size of a seagull, with a wingspan of 1 metre or 3 feet, Darwinopterus is characterised by its unique combination of basal and derived pterosaurian features. Possessing the long stiff tail and narrow toothy jaws typical of early pterosaurs, it also had a relatively long neck and the aforementioned large antorbital fenestra that characterised later pterodactyloids. It also would have had a prominent crest located on top of the snout, which was almost certainly used for display. Preserved remains of Darwinopterus eggs have shown that, like later pterosaurs, females of this genus laid soft-shelled eggs with a parchment-like leathery covering. These eggs were small in comparison to the overall size of the mother, with big clutches being buried in sediment and then covered over. The young were probably highly precocial and able to fly soon after hatching. This animal lived in terrestrial forested settings and was probably an active insectivore, bounding after prey both on the ground and in the trees. 3 species of Darwinopterus are known, and differ in the structure of their teeth, indicating that they specialised on different types of insects. Other well-known Darwinopterans include Wukongopterus, which was also native to Liaoning circa 164 million years ago, and is named after Sun Wukong, the famous monkey king from the Chinese epic Journey to the West, as well as Kunpengopterus, a small climbing genus that possessed opposable thumbs on its front feet, which is a rare trait in non-mammalian tetrapods. This is the oldest recorded instance of such a feature in the entirety of the fossil record. Other notable genera included Pterorhynchus from Inner Mongolia, which had a wingspan of about 85 centimetres or almost 3 feet, as well as a series of veins extending down the tail in a sawtooth pattern that were more extensive than those typically seen in other pterosaurs. As mentioned earlier, Some paleontologists, such as Dave Hone, have suggested that Darwinopterans may not have been a natural grouping, instead forming a grade within pterodactyliforms that led up to the pterodactyloids. This conclusion was reached due to the description of the transitional genus Scyphosaura, which was native to what is now southern Germany roughly 149 million years ago. Importantly known from an almost complete skeleton, this was a relatively large pterosaur for the time, with a wingspan of about 1.75 metres or almost 6 feet, comparable to a golden eagle. Its describers have also suggested that the type specimen may not have been fully grown. Notably, Scyphosaura combined a rhamphorhynchid-like head and neck, with a pterodactyloid-like short tail, long wrist bones, and a short fifth toe. All of the other taxa I've mentioned in this video had relatively long tails, which was a basal trait that was lost in pterodactyloids. This leaves the exact relationships of the bizarre short-tailed anurognathids pretty unclear, which have at times been classified as either very basal pterosaurs or as closer relatives of the similarly short-tailed pterodactyloids. These nightjar-like aerial insectivores were mostly native to Eurasia and first appear in the fossil record during the Middle Jurassic circa 165 million years ago, although if the mysterious Dimorphodon weintraubi is a member of this group, as has been sometimes proposed, it would push their origins back to about 189 million years ago. Unlike the Darwinopterans and many other small, somewhat basal Jurassic pterosaurs, these unique animals survived into the early Cretaceous, probably as a result of their very specialised nocturnal lifestyles. Regardless, the pterodactyloids first appeared during the second half of the Jurassic, with early forms being quite poorly understood and of controversial placement. However, ancestral members of this clade probably resembled the genus Diopecephalus, a small animal that was native to the famous Solnhofen limestone beds of southern Germany. Measuring about 20 centimeters long, with elongated jaws lined with small sharp teeth, Diopecephalus was probably a generalist insectivore or carnivore, combing the warm tropical beaches and islands of its environment. This animal has at times been considered to be synonymous with the famous genus Pterodactylus, which was also present in late Jurassic Central Europe, although a recent 2024 study by Robert Smith and Dave Unwin has found it to be a basal pterodactyloid instead. This study also indicated that Pterodactylus itself was an early member of another distinctive lineage that has traditionally been referred to as Archaeopterodactyloidea, but has more recently been dubbed the Eutinocasmoidea. These were some of the first truly large pterosaurs, taking part in a notable radiation of these derived flying reptiles that occurred during the early Cretaceous. Many members of this clade had very distinctive features in comparison to other pterosaurs, including the shape of their jaws, which were highly elongated and often very narrow, in addition to their incredibly specialised teeth. Early basal forms, such as the late Jurassic Bavarian Pterodactylus, were small and fairly generalised compared to what would come later. Known from over 30 often well-preserved specimens, most of which represent the remains of juveniles, this distinctive animal possessed an adult wingspan of about 1 metre or just over 3 feet, being about the size of a chicken when on the ground. Recent studies have found that this frequency of juvenile fossils was likely due to young animals being swept out to sea as a result of violent storms, with the larger adults being better able to avoid this fate. The jaws were straight, unlike the upwardly curving ones of its more derived relatives, with the numerous small teeth hinting at a generalist carnivorous diet. All other members of the clade have been classified within Tinocasmatoidea, including the genus Ardiodactylus, also from late Jurassic Bavaria. This long-legged animal was notably larger than Pterodactylus, with a wingspan of about 1.5 metres or roughly 5 feet. It possessed both an elongated neck and jaws, indicating that it may have been a wading piscivorous heron-like form. Ardiodactylus was an early member of the successful family Tinocasmatidae, some of which were incredibly specialised and bizarre. Many were also quite large pterosaurs for the time in which they lived, such as the genus Morganopterus from early Cretaceous Liaoning, China. Standing 1.2 metres or about 4 feet tall when on the ground, this somewhat stork-like animal had the largest skull of any toothed pterosaur, with greatly elongated narrow jaws equipped with at least 62 small pointed teeth. It also possessed relatively long legs, with the living animal being a proficient walker or wader, likely feeding on fish and invertebrates. It was once thought to be the most massive toothed pterosaur to ever live, with an estimated wingspan of up to 7 metres or 23 feet, although recent studies have downsized this to about 3.5 metres or 11 feet. Still a good size for its time. Other genera, such as the late Jurassic Gnathosaurus from the UK, possessed a rosette of longer teeth at the tips of the jaws, which were followed by dozens of much smaller teeth running along behind. The structure of its skull was quite similar to modern spoonbills, suggesting that Gnathosaurus was probably a wading genus that fed on small aquatic prey. Many species were adapted for filter feeding, with most of these being part of the subfamily Ctenochasmatinae. These included the genus Ctenochasma itself, which was a basal early form from the late Jurassic of Germany and France. With a name meaning comb jaw, this animal is distinguished mainly by its over 400 long, thin, curved and closely packed teeth, which lined its elongated and narrow snout. The teeth were so closely packed that they formed a comb, hence the genus name, and in adults they projected outwards away from the jaws, indicating a filter-feeding diet. Analysis of its scleral rings have suggested that Ctenochasma may have been nocturnal like some modern seabirds, with its wings being notably larger and longer than other members of the group, with a structure similar to that of Antarctic skuas. Its bizarre later relative, Pterodaustro, took these adaptations much further. Endemic to Argentina during the early Cretaceous, roughly 105 million years ago, this was one of the very last Ctenochasmatoids, standing about 1 metre or 3 feet 3 inches tall, and with a wingspan of 3 metres or 10 feet. This highly specialised animal possessed upward curving elongated mouthparts, with the lower jaw being lined with about 1,000 bristle-like modified teeth. Meanwhile, the teeth in the upper jaw were very small and rather conical. When combined with robust hind limbs and large back feet, both adaptations for wading and walking on slippery, muddy terrain, it's all but certain that Pterodaustro was a somewhat flamingo-like filter feeder, utilising its unusual teeth and jaws to strain small hard-shelled aquatic crustaceans from shallow freshwater rivers and lakes. Fossils of just such invertebrates happen to be very common elements of the Albian Age Lagarcito Formation, where Pterodaustro was found. The genus is known from multiple specimens representing a variety of different growth stages, from eggs to fully grown adults. Studies of the growth stages for this pterosaur have found that juveniles grew relatively quickly in their first 2 years, attaining about half of the adult size. They then reached sexual maturity, growing at a slower rate for 4 to 5 years before there was a definitive growth stop. It's also been found that despite possessing the typical pterosaurian ability to quadrupedally launch itself into the air, Pterodaustro's unusual body proportions, including a long neck, long torso and short hind limbs, would have made takeoff rather difficult. Like modern geese, it may have required frantic flapping and fairly low-angled takeoffs in order to get airborne. Unfortunately, despite being a very successful and cosmopolitan lineage, these pterodactyloids appear to have become extinct roughly 105 million years ago during the Albian, with Pterodaustro being the youngest known genus. This was roughly 10 million years before a seemingly quite severe pterosaur extinction event that occurred during the Cenomanian, with the causes of the Ctenochasmatoid decline being quite mysterious, perhaps linked to sea level fluctuations, anoxic marine events, and reductions in shoreline habitats. By the end of the following Cenomanian stage, several other distinctive pterosaur groups would also vanish, including the ornithochirids, tapajarids, and the zungaripterids, leaving asdarchids and pteranodontoids as the major late Cretaceous pterosaur groups. I'll be covering all of these weird and wonderful forms in future videos of their own, but this is where I'm going to have to leave things for now. Thanks for watching everyone. The next episode will be covering the very exciting news that the controversial Maastrichtian Tyrannosaur Nanotyrannus was actually a legitimate genus, and were not simply juveniles of Tyrannosaurus, potentially being close relatives to the Appalachian Dryptosaurus and Appalachiosaurus. See you again soon. Cheerio.